Sometime very soon, the largest machines on Earth will run out of fuel. For 15 years, tech giants built artificial intelligence by vacuuming up every word, image, and scrap of code ever posted to the public internet. But we have finally hit a hard physical limit. The public web is dry. There is nothing left to scrape, and the systems we built to learn are beginning to starve. Most people think the biggest bottleneck in artificial intelligence is faster computer chips. It is not. It is data. Research groups estimate that the supply of high-quality, human-written text on the public internet will be completely exhausted within the next few years. Every Reddit thread, every digitized library book, and every Wikipedia edit has already been read and digested by these models. If tech companies want their systems to get smarter, they can no longer rely on us. They have to start manufacturing their own reality. This crisis is forcing a radical pivot. Companies are transforming from data scrapers into data factories. Take specialized industries like satellite object detection. You cannot train an AI to find a rare, newly designed military vessel using public web images because those images do not exist. Instead, researchers are using layout-controllable diffusion models, like a system called AeroGen. These models do not just paint pretty pictures. They generate millions of hyper-realistic, pixel-perfect synthetic satellite images, complete with exact coordinate tags, varied lighting, and simulated weather conditions. The machine is no longer learning from our world. It is learning from a simulated copy designed specifically to teach it. To understand how a machine can teach itself without humans, imagine an automated car assembly line. Instead of humans testing the engine, the factory installs the engine, turns the ignition, and if it makes an unusual sound, a robotic arm instantly pulls the engine apart, fixes the specific piston, and tries again. In the AI world, this is known as a language model virtual machine. An AI writes raw code, compiles it inside an isolated digital sandbox, and runs it. If the code crashes, the computer compiler spits back the exact error log to the AI. The AI reads the error, rewrites the code, and runs it again. Once the code runs perfectly, it is automatically added to the training library. This creates a clean, verified feedback loop that completely bypasses human programmers. But this synthetic factory has a terrifying structural flaw. If you train an AI on data generated by another AI, and then use that new model to train the next generation, you trigger a catastrophic spiral called model collapse. Just like making a photocopy of a photocopy, each successive generation introduces tiny, imperceptible errors. The model slowly forgets rare words, filters out unusual human behaviors, and starts prioritizing its own clean, sterile outputs. Within just a few generations, the system loses its grip on reality and collapses into a state of digital dementia, producing nothing but repetitive, nonsensical gibberish. Even if you manage to avoid collapse, there is another threat hiding in the data stream. It is a mathematical vulnerability known as Byzantine corruption. When training massive models, companies distribute the workload across thousands of computers worldwide. If just a few of those machines malfunction or are hacked by an adversary, they can inject subtly poisoned data into the training pipeline. These bad actors can break the core optimization algorithms that help the model learn, throwing off its coordinate systems or introducing invisible backdoors. If the factory cannot verify every single machine in its network, the entire intelligence becomes poisoned from within. This technical bottleneck is triggering a massive shift in the global balance of tech power. The era of the open web, where any scrappy startup could scrape public data and build a competitor to Silicon Valley, is over. The future belongs entirely to those who own the proprietary data factories. Tech giants are aggressively locking down their ecosystems, building multi-billion-dollar synthetic pipelines behind closed doors to shield themselves from copyright lawsuits. If a company owns the generation engine, the training sandbox, and the final model, they own the entire intellectual loop. It is a closed system that shuts out the public, creating an impenetrable monopoly where the raw material of thought is manufactured in private silos. We are moving into a world where the line between human knowledge and machine generation is permanently blurred. The models of tomorrow will not be trained on what humans have actually done, but on simulations of what we might do. This shift could unlock breakthroughs in medicine, physics, and engineering that were once mathematically impossible. But it also means we are building our future on a foundation of synthetic assumptions. As we hand the keys of learning over to the machines, we have to ask ourselves what happens when the systems we rely on have never actually looked at our real world.